All right, we start out with let R be the shaded region bounded by the graph of y equals x e to the x squared. So we have to identify the equations. And so there's the curve x e to the x squared. Negative 2x is this line. And then it says, and the vertical line x equals 1, which is over here on the end. So this is x e to the x squared. That's negative 2x there. Find the area of R. So A is top minus bottom. So to find area, it's going to be the integral from A to B of just top minus bottom, dx. If it's top minus bottom, it's going to be dx. Right minus left is going to be dy. So we have integral from 0 to 1 of x e to the x squared minus negative 2x, so plus 2x in this case. This is not the calculator problem. So let's work this out. This is a great example of u substitution. I see a function and its derivative. So let's let u equal x squared. So du is 2x dx. I don't have an x dx in this. We don't have a 2x dx, we have an x dx. So let's multiply both sides by 1/2, and now I have exactly x dx. So now when we do the substitution, we have integral, let's just leave it like that, of 1/2 e to the u du, but then plus x squared. I know what the integral of that is. It's just going to be x squared. So we'll do that in one shot there. Well, 1/2, the integral of e to the u is e to the u, so 1/2 e to the x squared, because that's what u is, it's x squared, plus x squared, and now we're going from 0 to 1. So when we plug 1 in, we get 1/2 e to the first, plus 1 squared is 1, and then minus, when we plug 0 in, we don't get 0. E to the 0 is not 0. E to the 0 is 1. So 1/2 plus 0. And so the answer is 1/2 e plus 1/2, because 1 minus 1/2 is 1/2. B, right, but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. Well, the line, the slope of this line is negative 2. So if we go down 2, whoops, I missed it a little bit, down 2, about right there, and over 1, then I realize, well, that's down there at negative 2, and they certainly didn't draw this to scale. That 1 unit is longer than the 2 units going down. But we're going to rotate this around that line right there. That line goes right through that point. I don't know if that's critical to know that, but it does. And then this would be that 180-degree turn. So that'd be 180 degrees around, but of course we're going all the way around. Now, sometimes it's a little hard to visualize this, but we're taking this line and we're rotating it around that line, and this curve we're rotating around that. So that's kind of coming out of the board. Well, we have washer. Should I put it? Let's see if I have room down here. Yeah, I'm not evaluating it, so I just really need one line here. B, we have pi from A to B of pi big R squared minus pi times little r squared dx, because these washers are stacking up along the x-axis. Now, you're not going to see any big R and little r in any textbook. I'm saying the big radius minus the little radius, the big circle minus the little circle. So we can factor a pi out of this. We're integrating from 0 to 1 in this case. Now we have to find out what the radius for the big circle, the radius for the little circle. Well, the big circle goes from this curve down to the center, or that line. And it's really, again, it's top minus bottom. It's the curve minus negative 2. So x e to the x squared minus negative 2, or plus 2, squared. That's the big circle. And now minus the little circle. So that radius is going from the line to the line. which is negative 2x minus negative 2 or plus 2, and then dx. Write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. Does everybody have A written? I'd like to erase it. It's okay if I erase A? All right. I need some room. There, that's room. Okay. C. I'd like to erase this too. Get it nice and clean. Negative 2x, x e to the x squared. And we need the perimeter. Well, this we said was down here at negative 2. So this distance from here back up to here, that's 2 units. And if I plug 1 into x e to the x squared, that's actually going to be e. 1 times e to the 1. So that side over there has a length of 2 plus e. This line right here is really the hypotenuse of this right triangle, which that's 2 units, that's 1 unit. So the hypotenuse is the square root of 4 plus 1. So we also have a distance of plus square root of 5. And so that's really the non-calculus part of this. All right, now the calculus part is the length of a curve. The length of a curve is the integral from a to b, square root of 1 plus dy dx squared, and in this case, dx. That's the length of a curve. And you get that from the Pythagorean theorem. Because you could go, well, I'll use this line for some of the length, and that would be this rectangle, or that triangle right there, that right triangle. And then the rest of it could be that hypotenuse of that right triangle. Well, using 2 triangles wouldn't be very accurate, so let's use 1,000 of them. Let's use 1 billion. Let's use 1 trillion. You know, we're going to infinity, right? But then the triangles keep getting smaller and smaller and smaller. Well, that's exactly what integral is. So we used the Pythagorean theorem to come up with this formula right here. So now that's going to be plus integral from 0 to 1 of the square root of 1 plus the derivative squared. And that's what we need to fill in. We need to fill in the derivative of x e to the x squared. So that's first times the derivative of the second, right? Chain rule times 2x. So we have first derivative of e to the x squared is e to the x squared, but then times 2x. Plus the second, e to the x squared, times the derivative of the first, which is just 1. So if you want to represent it, it's 1. So if you look at the rubric, they like to factor stuff out. So that's 2x squared plus 1. And we got to square that. So e to the x squared, 2x squared plus 1 squared dx. And there it is. And they really asked you to find the perimeter for this. But you need the rest of it. But that's why they asked you, to see if you know the length of a curve. That's the calculus part. Any questions on this problem? All right, here we go. We got one more. Oh, here's the rubric. 1 for the integrand, that's getting this correct. 1 for the antiderivative, that's getting this correct. And then 1 for the answer. So pretty straightforward on that one. 2 for the integrand, I would go 1 here and 1 here. 1 for the limits and the constant. In other words, that right there. So that'd be 1 point. 1 for the derivative. So I would look in here to see if you got the derivative correct, or if you wrote it anywhere else in your work. Integral, I guess getting the rest of this correct. And then 1 for the answer. So I had to assign 1 to that. Since I assigned points to the rest of it, that's probably worth 1 right there. Or if you forgot to add, I don't know. There's lots of different scenarios, I suppose. Let R be the region in the first quadrant bounded by the x-axis in the graphs of y equals natural log of x and y equals 5 minus x as shown in the figure above or off to the side here. A, find the area. So now we're going to do area is the integral, integral from a to b of right minus left. But then if we do right minus left, we're doing that with respect to y, because these curves 1 is always to the right. This line is always to the right of the natural log of x up to that point. Well, if we're going to do this with respect to y, we have a problem because these are in x. So we have x is e to the y, and if I add x, let's minus 5 over and divide by negative 1, x is 5 minus y. Now we have functions in y. So that's the first thing we'd have to do if we're going to do right minus left for this. This is a calculated problem, so let's find the intersection point. I'll pretend I haven't done this yet today. Clear that out. So we go to, here's our calculator. We're going to go to y equals, and we're going to go natural log of x. The other one is 5 minus x. We can't do it in y on our calculator here. The window I set to, and I kind of used the graph to guide the window. 0 to 5 seemed reasonable, and 0 to 2 seem reasonable on the y. Because it's slightly above 1, it seems like. So I'll go to 2. Now this should be fairly close to what you see on the AP problem. Now we're looking for that intersection point. So we go second, calculate, intersection, and we go first curve, second curve, and this says guess, and what it really is saying is go to the intersection point that you want the answer to. So here's what AP does, and we can borrow their little method. They say AB is equal to 3.6934414 and 1.3065586 is B. Now we can use A and B instead of writing out the entire number. It only takes a couple seconds to write that out. So now to find the area, we're going to go integral from 0 to B, because we're doing this with respect to y. We're doing right minus left. The right function is the line. That's 5 minus y. And the left function is e to the y, dy. So now because I did that intersection point, I can go math number 9. We can go from 0 to, you can type that number in if you want, 1.3065586, or you could go alpha 1, which is the y. So alpha 1, and that number, that y is holding that number in there because we found the intersection point on the graph. So then we go 5 minus, now here we run into a little problem here. I could put y's in there if I wanted to, but it's much handier to just hit that button and use x's. You guys okay with that? See what I'm saying? The variable doesn't matter now, not in this part. So I'll use x even though that says y minus e to the x. And we're doing it with respect to x. And I could have typed alpha 1, alpha 1, alpha 1 for the x's and just did everything with y. We could have done that too. But that, I believe that is the answer. I hope anyway. I got the rubric, so we'll check. 2.985 or 2.986 is the answer to that one. B is all about cross sections. Region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis, perpendicular to the x, is a square. Right, but do not evaluate an expression involving one or more integrals that gives the volume of the solid. All right, well now what they're saying is we're kind of laying this xy plane down, like on the table, and we're raising up squares from this. So here's the natural log, something like that, and here's the line. So now we have squares following the natural log of x until we get to this intersection point. Then after that, those squares are now going to follow the line. So they follow the natural log, then they follow the line once they get past that intersection point. So I need to integrate from 0 to, we called it a, from 0 to a, and it's really side squared dx. Then once we get past a to 5, we have more squares in x. but we need it in x, not in s. Side squared is the area of the squares. So it's really 0 to a of the natural log of x squared dx, dx plus a to 5 of, well, I need, is it 5 minus x? Yeah, 5 minus x. So we're following the natural log. Now we're following the line. 5 minus x squared dx. And they're telling you, do not evaluate it. C. The horizontal line y equals k divides R into two regions of equal area. Right, but do not solve an equation involving one or more integrals whose solution gives the value of k. This is way easier than students give this credit for. Students typically think this is really difficult. Oh, I messed up. I have a mistake on B. Anyone know what it is? I just caught it. I'll come back to C. One to A. Very good. Good catch. Natural log starts at 1, not at 0. 1 to A. 1 to A. I mean, it's a small mistake. I'd probably lose 1 point off of that. But, I mean, it's 1 to A, not 0 to A. Okay, back to C. Yeah, students make this really tough. But they're saying that there's this horizontal line that cuts this in half. And it's not necessarily a half. And it probably isn't a half. It isn't that easy. But there's some line here, k, that cuts the area in half, and we want an equation that would solve for this. So we would integrate from 0 to k of right minus left, and we have that. We have that up here, actually. 5 minus y minus e to the y dy. Somewhere I can get a k that would be equal to half of the area, 2.985. And if we did the integral on the left side and we solved it for k, we could actually find the number, but they say don't do that, just set it up. That's it. Somewhere there's a k that's half the area. Done. So like I always say, if you're doing tons of calculations on the AP test, you're probably doing something wrong. This is probably, I don't know, we might do a little more than that at times, but that one was fairly involved. So you shouldn't be doing lots and lots of calculations on this test, ever. Let's look at the rubric very quickly. Notice how I told you they do this right there, and now you can use A and B anywhere you want. It makes the integral look a little cleaner, but you could have put the number here as well. You didn't have to put B. Yeah, so one for the integrand, one for the limits, one for the answer. Round or truncate. 2 for the integrand. I would go 1 here and 1 here, expression for total volume, and then I would look to see, did you have the integrals right? Did you add them together? Probably lots of ways you can mess that up. Integrand, boom, limits there, and then did you write the overall equation correct? Overall, is it right? That'd be worth a point. I'd probably mostly look at that right there for that last point, I would imagine. All right, let's talk about multiple choice. What's the slope of the line tangent to the curve when y is 2? So I got to do derivative for slope of the tangent, and we got to find out the x for when y is 2. So there's no order to it. We could do either one, but we're going to have to find the points. So let's do that first, I guess. X squared minus 4x minus 20 is equal to negative 15. So I plugged 2 in for the y's. Add the 15 over. Factor. So x is 5 and x is negative 1. So we have 2 points to look at, 5, 2, and negative 1, 2. So a little algebra for you. Now it asks us for the slope of the tangent. That's derivative. So this is implicit because we have x's and y's in this equation. So as long as we're taking the derivative of x, it's proceed as normal. If we're taking the derivative of y, that takes the chain rule. So now we have first times the derivative of the second. And the derivative of y is 1, but you got to multiply times the derivative of the inside, which we represent with dy dx. Plus the second times the derivative of the first. Now if we take the derivative of x, we're good. We don't have to do anything extra. Minus 10y dy dx is equal to 0. Don't forget to take the derivative of negative 15. Well, now we need dy dx by itself. So let's factor dy dx out. That'd be negative 2x minus 10y. And we'll get everything else to the other side. So that would be negative 2y. So over on the other side, we'd add that over. And then we would minus 2x. So dy dx is equal to, how about this, y minus x over negative x minus 5y. So factor a 2 out of the top, factor a 2 out of the bottom, and maybe that'll make the evaluation go a little easier. Then the 2's would cancel out. And we're going to evaluate that at 5, 2. So 2 minus 5 is negative 3. And then negative 5 minus 10, negative 15. That's pretty clean, 1/5. Now we're going to take dy dx, evaluate that at negative 1, 2. 2 minus negative 1, that's 3. And then negative 1 minus, no. I don't remember being a negative 11. 1, not negative 1, thank you. 1 minus 10, negative 9, negative 1/3. There we go. Negative, negative. Try not to make those silly errors. I can do that. You don't do that. U substitution is this next one, because I see a function and it's a derivative. I see a power of 2 and then a power of 1. So we go u is equal to 1/6 x squared plus 1. Then the derivative is 1/3 x dx. Well, we don't have a 1/3 x dx. We have just an x dx. So 3 du is equal to x dx. Well, now we're going to integrate times, we got times 3 du, and it's the square root of u. Now we can do the integral on u and then plug the x's back in, or I can just change everything to u's, because this is x equals 0 to x equals 18. If I plug 0 in for x here, 0 plus 1 is 1. Now I can go from 1. If we plug square root of 18 in for this, 18 divided by 6 is 3. 3 plus 1 is 4. So now if I change everything to u's, I can just do everything with u's. This is u to the 1/2. So u to the 3/2 times 2/3. I got to bring that 3 with it. And now we can go from 1 to 4. So 3 times 2/3, 4 to the 3/2 minus 2/3. Why did I write 3/2? 2/3. Times 1 to the 3/2. All right, finish it. We got to be able to do everything. And sometimes this is where we get stuck. This is where we get hung up. see, square root of 4 is 2. 2 to the third is 8. That's 16 thirds. And then minus 2 thirds. Well, that's 3 times 14 thirds. So we're looking at 14. There we go. Do the root first. Do the square root first, and then raise that to the third power, and that's usually the easiest way to go with that. All right, last one here on multiple choice. The derivative here, we got the product rule and the chain rule, and we kind of already practiced it. Kind of already had this, where'd it go? Back here, with x e to the x squared. So we've kind of already done this, so let's do it one more time here. First times the derivative of the second. So there's first times the derivative of the second. You got to remember that chain rule, times 3 plus second times the derivative of the first. Now, I told you this is really for multiple choice. And so you're going to have answers that you're going to try to find. And, well, maybe this is the answer. I doubt it. Or they could take a e to the 3x out and go 3x squared plus 2x. So you might be looking for that one. We could also factor an x out. So maybe you're looking for this one. So you have to be able to simplify. You have to be able to rationalize. You have to be able to alter these expressions so you can find the answers in multiple choice. So whenever I get the question, do I have to? It's usually, well, yeah, what if they do that on the multiple choice? What if they rationalize the denominator? What if they factor stuff out? You'll have to go find it. All right, if you're watching this at home, we're going to do this together, or as in pairs. So with your buddy, try this one. So you might have to fast forward a little bit if you're watching this at home. This is a calculator problem, by the way. Lots of decimal answers. Don't integrate by hand.
All we have to do is from this intersection point to this intersection point, we can find these intersection points and do the integral of this.
Yeah, because
Actually,
you make intersection points like this will give us our x values.
So the area can't be
Okay, so it works both. Both
Yeah.
ways for this one? Okay, gotcha.
I think it's just this.
It's like
This is right, but do not
if I'm 60 alive.
evaluate it. It's a real expression.
Oh wait, I also need to put
What we doing back?
y equals negative 2.
If we don't know where we
Oh, we need 30. So that the first x value is at. I guess.
So it should still apply.
What?
Oh, you do it where it intersects at -2. Right? So we're subtracting.
Yeah, but then not just.
It might be it. I'm sure it makes sense, but I'm just not. I'm not there. Maybe made it.
Well, I entered my calculator. Right there on the top.
Yeah, 21. Yep.
R division of the R basis of.
You literally entered a -2 into the line.
Okay.
Yeah, but we still.
Did you get 4 for A?
Yep.
Yep.
Yep, 4.
Why for
That works out nice for being sine.
Because
So okay, if it's
well, we used to we just add all these up, and now we're just
So intersects at K.
so is this is it like saying that there's like a shape or something like that?
yeah. It's saying
So that's right there.
from each of these. we're
You
drawing
find the
a
area
square
underneath it,
out.
subtract it from the area.
I think I would imagine that.
There's B. Had to find those intersection points.
That's probably from 0 to 1.
Yeah.
You gotta do something different from.
B's actually, well, I mean, I can say this a lot in calculus. It's fairly simple in that you have this line at -2, and if you find those two intersection points, you would integrate from, if I called that A and B, I'll skip finding the values. You can see the values on the rubric. I'd integrate from A to B, and then it would be, the top would be -2, and then minus whatever this curve is, that x to the third function, right here. Minus x to the third minus 4x dx. So the work would be in finding what those a and b values would be, the intersection points. Then it's just top minus bottom. And that's exactly what they're showing here. So they found the two intersection points, and it just ends up being top minus bottom.
Whoopsie daisy.
I'm still pretty sure that works.
For the next one, it's top minus bottom squared, because that would be side squared. There, the cross sections are squares perpendicular to the x-axis. So the side is sine of pi x minus x to the third minus 4x, top minus bottom. Well, then you're going to square that, because that's how you find the area of a square. Ends up being 9.978. Now, letter D's been the tough one. This is the one where it separates the 4s from the 5s. But you need to integrate a cross-sectional area. So this is the depth, and this would be like the width. So if you take any two dimensions of a three-dimensional object, and then you integrate it, your third dimension is sitting right there. There's your third dimension. So the depth times the width, there's a cross-sectional area. Integrate that, third dimension. So this one's a little, that one, I thought that was tough. And then punch it into your calculator and get the answer.